Okay, so relations in which an element of the domain values, which are x, very important word, domain is always x, is paired with exactly one element from the y, and the y values are called the range values. When that happens, when an x goes with exactly one y, it is called a function. Now, there are some easy ways to determine if it is a function or not. And the easiest thing I know to tell you is that the x's, so look only at the x's, do not repeat. So when you look whether they are in ordered pairs, in a table or a graph, and we're going to look at those different examples, but the x's do not repeat. If the x's do not repeat, then it is a function, okay? So in all these, we're going to determine if it's a function or not. So what I want you to do is I want you to look at the x value. Now, some of you can't see when I underline or highlight, so I'm going to underline the x values. That is your domain, okay? I have a 4, a 2, a 6. They're all different, so no repeats. If the x's do not repeat, then it is a function. Now I'm going to look at the x's over here. I have -3 and -3. Oh, see, they're the same thing. So this is not a function. And the reason it's not a function is because of the repeat. Okay? Because of that guy right there, the -3. Since he repeats, it's not a function. All right? Let's look at a graph. Now on the graph, I think I'm going to pull up a reveal tool because I think this is going to help you out. On the reveal tool, and I'm going to pull from the side. Now notice, whenever I'm pulling from the graph, it only cuts that red line one time. Okay? And I'm going to go over this with the highlighter so you can see that this is my graph, because some of you may be saying, what are you talking about? Okay, there's my graph. When I pull the reveal tool, starting from the left side, so you always read it starting from the left. That's how you always read a graph, just like a sentence. That black line just cuts through it one time, and I'm just going to scroll it over. It only cuts through, one place. Every single time, it only cuts through one place. So this is a function, okay? And that is by the vertical line test. This black line creates like a vertical line. This is called the vertical line test. My black reveal tool is making a line up and down. And if it only crosses the graph, the picture of the graph once, now when I say the picture of the graph, I mean the image on the graph. So like on this one below it, it would be this line right here. So I'm going to go back and I'm going to do that again. Starting from the left, it only crosses through it. That black line only touches it one time. Every single time. So this is a function. Okay. Now, we won't always have functions, but those two are functions because it won't ever touch it. Okay, let's look at these two. Now, these two do have color, but I'm going to go over them. So this one I'm going to go over in red so you can see it, and this one I'll go over in red as well. Okay, now I'm going to go back. So when I look at it, if it's going and crossing it one time, if the black line is only touching it once, it's fine. That's okay. That's okay. Oh, see right here? It crosses twice. See that black line touches it twice. And that could have happened anywhere right here. It counts as twice. So this is not a function. Okay, because it crosses it more than once. And look right here, you can tell. It crosses it, that crosses 3 times when I draw my vertical line. If I were to draw a vertical line right there, it would touch 3 times. So that is not a function. Okay? These, and I draw a vertical line, it only hits once. This is 3 times. So a function, vertical line, so the up and down line, touches 1 time. Once, okay? And this one, the vertical line, when it's not a function, it will touch your graph. And when I say the graph, I mean the design more than once. It can be twice, it can be 3 times, but if it touches it more than once, it's not a function. Okay? So, we've got two more, and I'm gonna highlight these just so you can see them. And I want you to try to tell me if they're a function or not a function. And I'm gonna use this reveal tool, and you can just use a sheet of paper and start from the left and start sliding it over and start looking at it. If it touches it only one time all the way through as I'm sliding it, then it's a function. But if it crosses it more than once, then it's not a function. Okay, so you can tell me if you think those are a function or not. All right, now if I have a table, so again, I am looking at the x values. You only want to focus on the x values, which that is your input. So I'm going to look at my input value, okay? And I'm going to look to see if any of these repeat. -1, 0, 1, 2. They're all different. If they are all different, then it is a function. I'm not looking at the y's, I'm only looking at the x's. On this table, 3, 4, 5, 4. Oh, here's a 4 and here's a 4. See, 4 goes with 7 and 4 goes with 14. I can't do that, so this is not a function. If the x's repeat, then it's not a function. On your graph, it would be like 1, 2, 3, 4, and then you would go up to 7. Okay, there's 4, 7, and then you go 8, 9, 10. See, when I draw a vertical line over 4 and 7, see how it hits both those dots? By the vertical line test, it goes through both of those dots. Okay, so that's why it's not a function, but you can tell it a table because the x's repeat. Okay, what if we have a map? So on a map, again, I'm gonna look at the x column, and if it just has one arrow going from it, then it is a function. So the first one is a function. Look at the second one. The -4, and I just want to look at the x column. This is the one that you want to focus on. So just focus on the first one. All right, so -4 has 1, but look at -1. It has 2 going from it. That would be -1, 4 and -1, 7. See, I have 2 -1s, so that is not a function. So you can tell because the arrows, okay, there's 2 arrows leaving it, okay? I cannot have that. So let's look at this one, 10, 4, oh, right here, 2 arrows, 2 arrows. So this is not a function. Remember, I'm not looking at the y's, I only want to look at the x's. And then the last one has 1 arrow, 1 arrow, 1 arrow, 1 arrow, 1, 1. So this is a function. If it only has 1 arrow from each x, then it is a function. Okay? 1 arrow from each x. Then it's a function. And that is it. Now, there is one last question that I have for you, and it is this one. At the end, you're going to have some tables, and it wants you to answer some questions. So the questions are, is this relation a function? And remember, if it's a function, you look at the x's, okay? You want to look at the x's, and I want to see if any of those repeat. So I'm going to look at my x's, 0, 1, 2, 3, 4, 5. There's no repeat. So is it a function? Yes. Okay? Because the x's don't repeat. No repeating. So it's a function. The independent variable. Remember that your independent variable is always, always, always the first column. Okay? So the independent is always your x. And in this case, my x value, it's always the first. In a table, it is always the first one. So look at the label. The independent variable is t, and it represents seconds. The dependent is always the second one in your table, and that is my y column. And the y column, that's always your y. This happens to be d, and that represents feet. Now, normally, people will use variables that represent the word, and they have the first same letter. But sometimes, like time, they use seconds because there's different measurements for time, hours, minutes, so they use T. D represents distance, and so the distance in this case is feet. So D represents distance, and in this case, they're using feet, and T was time, and in this situation, they're using seconds. Domain values. So remember, domain is the first column, which is your X column, and my domain values, my domain values are 0, 1, 2, 3, 4, 5. The range values are always the second column, and in this case, they are 7, 10, 13, 16, 19, and 22. Now, on the bottom of your page, I want you to write this down because some of you still struggle with this. I want you to write A equals, we're going to do just a couple of these. A equals 25W, okay? Remember, the very first thing you do is look for multiplication. So this right here, the one that's by multiplication, this is my independent. So my independent is W, which stands for width. My dependent is the other variable. So my dependent is the other variable A, which represents area. Okay? So if I give you another one, and I'm going to throw these in because I want you to get them. So let's say that P equals 4 plus 3Q. Okay? Let's identify which is the independent, which one's the dependent. Okay? You look for multiplication. This right here is multiplication. So Q is my independent. Okay? And that means P is my dependent. The one that's by times is always your independent. Always, 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 always. What if, and write this one down, so I want you to try this one. T equals 2R minus 4. I want you to try that one. And then I want you to try this one. S equals N divided by 5. No, I'm not going to give you that one because that one would not be fair, so I'm not going to give you that one. Let me do an undo. I'll do 5N minus 10. So tell me the independent, dependent, and I want to know those tomorrow, what the independent dependents are.